Good day to everyone. Our topic for today is how to graph an ellipse centered at the origin. In this video, you will learn how to sketch ellipses with accuracy and precision, grounded on their algebraic foundations. Before we proceed, kindly like this video, subscribe to the channel and click the notification bell to stay updated with my latest lessons. So, what is an ellipse? An ellipse is the set of all points, where the sum of the distances to two fixed points called foci is constant. Visually, it looks like a stretched circle with two axes, the major axis longer and the minor axis shorter. When the ellipse is centered at the origin, it is perfectly symmetric about the point 0 and 0. The standard equations of ellipses are written in two forms. If the major axis is horizontal, the equation is x squared divided by a squared plus a squared divided by b squared is equal to 1. If the major axis is vertical, the equation is x squared divided by b squared plus e squared divided by a squared is equal to 1. Here, a is the length of the semi-major axis, while b is the length of the semi-minor axis. There are key attributes of ellipses that we need to remember. The center is at 0 and 0 for origin-centered ellipses. The vertices are the endpoints of the major axis. The co-vertices are the endpoints of the minor axis. And the foci are points located inside the ellipse, along the major axis, closer to the center than the vertices. Now let's graph ellipses step by step. Step 1. Determine the orientation. Compare the denominators of x squared and y squared. In the equation, the larger denominator corresponds to a squared, which tells us the direction of the major axis. The smaller denominator corresponds to b squared. For example, x squared divided by 16 plus y squared divided by 9 is equal to 1. Here, a is equal to 4 and b is equal to 3. Since a is greater than b, the major axis is horizontal. Step 2. We calculate the foci distance. The formula is c is equal to the square root of a squared minus b squared. This guarantees that the foci are always inside the ellipse. For the equation, x squared divided by 16 plus y squared divided by 9 is equal to 1. The foci are at points 7 and 0 and negative 7 and 0. The third step is to plot ellipse. We mark the center at the origin, plot the vertices and co-vertices, locate the foci for reference, and then sketch the smooth curve of the ellipse. Let's try an example. X squared divided by 36 plus y squared divided by 9 is equal to 1. Here, a is equal to 6 and b is equal to 3. Since a is greater than b, the major axis is horizontal. Vertices 6 and 0, and negative 6 and 0. The co-vertices are 0 and 3, and 0 and negative 3. And the foci are square root of 27 and 0, and negative square root of 27 and 0. Another example. X squared divided by 16 plus y squared divided by 36 is equal to 1. Here, a is equal to 4, and b equals 6. Since b is greater than a, the major axis is vertical. Other values like the vertices are 0 and 6. And 0 and negative 6. The co-vertices are 4 and 0, and negative 4 and 0, and the foci are at points 0 and 2 times the square root of 5, and 0 and negative 2 times the square root of 5. Sometimes, ellipses are given in non-standard form. For example, 4 times x squared plus 25 times e squared is equal to 100. To find its features, we first convert it to standard form. By dividing every term by 100, resulting to x squared divided by 25 plus y squared divided by 4 is equal to 1. Here a is equal to 5, b is equal to 2, and the major axis is horizontal. In summary, to graph ellipses more accurately, follow a systematic approach. Apply the key point method. And most importantly, remember practice makes perfect. Thank you for watching.